Okay, so the cross product of a couple of vectors. The cross product is actually a very useful uh, thing to have in robotics because if you have, let's say, x, y, and z here, if you take the cross product of x and y, it will give you z. So that's the point of a cross product. So a quick example here, just to see how it goes, is to jump right into it. Is the best way to see it is x is equal to say 1, 3, 5, and then y, get my terminology correct there, is equal to say 2, 1, and negative 1. There we go. So if you take x cross y, this is the tough part because you have a cross in here, and if you are used to using multiplication as a x, you're going to need to change that because you'll get confused between cross products and multiplications. So the way you're going to do this is actually equal to, okay, so going through here, 3 times negative 1, I'm just going to put a bunch up here so we can get through it, and then 5 times 1, minus 5 times 1, and then 5 times 2, I'm going to write these out just to show how they came from, and then I'll explain it here. 1 times negative 1, and then 1 times 1, minus 3 times 2. So what the heck did I just do? Yeah, okay. So what you're doing with the cross product is actually really similar to the determinant, but a little bit different. So what you'll do when you're taking the cross product of two vectors is for the first row, you'll cover the first row of the two vectors, and then do the cross product of these values. So you'll do 3, cover this up, then you'll do 3 times negative 1 minus 5 times 1. And then moving on from there to the second column, you'll cover the second column in the vectors. Then you'll do 5 times 2 minus 1 times negative 1. And you'll see that the order has actually switched of how that multiplication goes, which is a funky thing to do because right here we had 3 times 1 and then 5 times 1, and now we're doing 5 times 2 and 1 times 1, so negative 1. And then we'll actually flip the order again. When we go down here, we cover this one up, and then we go 1 times 1, and then minus 3 times 2, and that's your answer. And then you work this out, and you get negative 8, 11, negative 5. So that is how you do the cross product. It's can kind of be a little bit confusing at the beginning, but once you get used to it, it's not that bad. If you want to look at it another way, x cross y is if you have is technically equal to, if these are vectors, you have a vector of x1, x2, x3, and y1, y2, y2, y3. So x cross y, when y is equal to this and x is equal to this, you go and the result is x2, y3 minus x3, y2, and then x3, y1 minus x1, y3, and then you go x1, y3 minus x2, y1. So that's basically how you go about it. If you want to, since the cross product is basically the determinant, another way of looking at it is if you take the two vectors, and take the transpose of them and put them into a matrix of I, J, K. Then you've got x1, x2, x3, then y1, y2, y3. And then you basically take the determinant of this, so x cross y is equal to this, put those to this, and then you put in, basically take the determinant of this matrix, which is equal to x2, if you cover up this row of I, then you're in the I column, or the I row, and you've got x2 times y3, minus y2, x3. And then if you move on to the middle column, which is the middle row, you go to you put in a minus because you're switching signs and doing the determinant of y1 x. Sorry, did that wrong? That confused with where I was. Minus x1 y3 minus negative y1 x3, which goes to plus, and then put this next row in here because this minus was actually distributed through here. Because you know how when you do the determinant, you have a negative sign for the second value that you calculate. So we put a negative out here, and we put a negative out here, and that cancels with this negative. So that's where these two negatives come from. And then we go to this one. We go x1, y2, top minus y1, x2. So I'm going to actually put this back to a negative so I can make this point a little clearer. If you were doing the determinant of this, you would actually line up all these rows, or all these values, into one single column and calculate the determinant. But instead of doing that, you consider each one of these columns as one of the rows in the cross matrix. And then what would normally be negative minus all this minus that, you distribute that negative through here. If you were doing the determinant, I don't have space to show you the determinant, so you're going to have to go review a determinant to see what I'm talking about. But the second value of a determinant always has a negative in front, so we distribute that through, and you end up with a plus plus, and then you go through and do the cross product again. So this is an easy way to remember how to do the cross product for normal values up here, and why this funky kind of switch happened right here. It's just the result of the cross product being based off of the determinant.